These are the solutions for homework 2.1.2. Let's look at 217. Simplify each algebraic expression below if possible. If it is not possible to simplify the expression, explain why not. So look at the first one. It's a 3y, 2y, plus y squared plus 5 plus y. So watch as we first find the like terms. They are y squared, 3y, 2y. 3y and 2y are like terms along with y. And 5 is a unit all by itself. So we just combine them. Y squared plus 2y plus 3y plus y is 5, 6y. And then plus 5. That's it. Notice how y squared goes first, and then you have 6y, and then there's 5. Let's do the next one, b. Wonder if I can... Yeah. So let's take a look at the next one, which is b. So b is, we want to find the squared exponents first. There's x squared and there's y squared, and we want to put them in order this time. So there's only one of each, so watch. We have 2x squared plus 3y squared. Now those are done. And then we have an odd term here, this 2xy. Remember we talked about the x, y. This was x, and this is y. And that was called the x, y tile, right? The xy tile. So this one goes next, plus 2xy. And then we have an x, so that's done. And now we have a 3x and a y. So that's plus 3x plus y. And then we have a 1 unit here. Tic-tac, 1. We're done. So, this expression cannot be simplified, right? It says if it's not possible to simplify the expression, explain why not. Yeah, so that expression cannot be simplified. And that's because it's already in simplified form. So that can't be simplified. But the benefit of this is that it shows us the order, the arrangement, the standard in which we should organize our equations. Let's move on to C. C is, look for some x squareds here. We don't. But the highest, the one that should go first is 3xy. Because it is the most, it is more complicated than your 5x and your 3y. So we'll add plus 5x and add, looks like we made a mistake here. What mistake did we make? Well, we overlooked that there's actually another x here. Here's another x. So it shouldn't be 5x, it should be 6x, right? So those are taken care of. And then what comes next? Plus 3y. And then there's a 2 and a 4 here. And that's plus 6. Great. So we have 3xy plus 6x plus 3y plus 6. That's the answer for C. We did simplify it. We combined the 5x and the x to get 6x right over here. Right? If you remember, combined 5x and x to get 6x. Otherwise, oh, and we combined the 4 and the 2. Let's take a look at D. Wow. This one looks a lot more complicated. It's 4m plus 2mn plus m squared plus m plus 3m squared. Well, not really. All we need to do is combine our like terms, start with the squares. 3m squared plus m squared. How many m squares are there? There's 3 here, and there's 1 here. That's 4m squared. And then our next most complex term is the 2mn plus 2mn, and then m and 4m. So that's plus how many m's? That's 5m. That's it. That's 217. Let's move on. If tiles have the dimension shown at the right, what is the name of the tile collection below? That is, what is the total area of all the pieces? So, wow. So, there's quite a jumbo here, but this is what we're going to do. We're going to go step by step and find the different tiles, and then we're going to quantify. Really, math is really a lot about organization. So what we're going to do is we're going to get organized here. We recognize all our tiles here. This is our XY tile here. This is our Y squared tile. This is our XY tile. That's kind of hard to see. This is our X squared tile. This is our Y bar. And this is our X bar. So let's take a look. How many of our X squared tiles do we have? We have 1, 2, 3, 4, 5, 6. So there's 6 of those. How many X bars do we have? Well, there's 1, 2, 3, 4. I don't think I've missed any. So that's 4. How many Y bars do we have? So that's 1, 2, 3, 4, 5, 6. So we write a 6 in here. How many XY tiles do we have? That's 1, 2, 3. I don't think we've missed any. That's 3. And then how many Y squared tiles do we have? Well, I only see 1 right there. So that's 1. All right. So now that we've taken an inventory of all our tiles, the next thing we need to do is we need to write an equation. So let's do that. Remember, we start with the exponent. So in other words, an x squared or y squared, and we start with the most complicated variable. So an xy or an x squared or a y squared. So we do have an x squared, right? Do we have 1? No, we have 6. So it's 6x squared. So that's 6x squared. So we're good there. How many y squareds do we have? We have 1. It's plus y squared. How many xy tiles do we have? We have 3. So we just add 3 here. 3xy's. How many x bars do we have? We have 4. Plus 4x. And how many y's do we have? Y bars? We have 6. Plus 6y. Now remember, we just put everything in alphabetical order. I mean, first we put things in order of complexity. So in other words, if it's an x squared, a y squared, if it's an xy, those will go first. And then we put it in alphabetical. That's it. Alphabetical order, right? That's it. We want to just stay organized. That's done. Let's take a look at 219. It says, remember that one meaning of the word evaluate is to replace a variable with a number and to calculate the result. For example, evaluating the expression x squared when x equals minus 2 results in the solution minus 2 squared is equal to 4. So all we're going to do here is just like in 2.1.1. If you see a variable, you just replace it with the definition of the variable. Okay, so this is really basic. Let's do these one by one. So if we have minus 4d plus 3 and d is equal to negative 1, we have minus 4, d is negative 1 plus 3. Okay, we remember the rules. Minus 4 times minus 1 is a positive, so this becomes a 4 plus 3. That's it. So that's 7. Again, we do multiplication first here because of order of operations, and then we do addition, right? It's part of PEMDAS. So multiplication is before addition. So the answer here is 7. Let's do the next one, B. B is K minus M, where K is 4 and M is negative 10. So we can just do that right away. K minus M, where K is 4, minus M is what? Minus 10. Now there's a little review going on here. We're reviewing our rules of subtracting and subtraction. So that's 2 minuses make a plus, so 4 plus 10 is equal to 14. So let's try to visualize this a little bit. Why is 4 minus minus 10? Why is 4 minus minus 10? We'll get into that in a moment. Okay, let's just focus on the rule for now. Let's keep moving on. So that answer is 14. This is 14. And we'll still get C. So it's t over w, where t is t over w, where t is 6, w is -3. Whenever you divide any number by a negative number, it becomes negative, so this becomes 6 divided by -3, which should be -2. So this is -2. X squared plus y squared, if x is equal to 7 and y is 5. So that's x squared plus y squared is equal to 7 squared plus 5 squared. Alright? So 7 squared is 7 times 7, which is 49. And 5 squared is, of course, 5 times 5, which is 25. That should be 74. Another way to mentally do this, 50 plus 25 would be 75, so just taking one away would be 74. So D is 74. Let's take a look at 220. 220 says, a small bag of colored candies has about 135 candies in it, 27 which are blue. At this rate, how many blue candies would you expect to be in a pile of 1,000 colored candies? So this is a proportion problem. I think we were working with proportions only 2 weeks ago. Let's see how this would work. So we have to create a proportion. So we want to go, there are 135 total candies. So this is, in the first set, there are 135 total candies. In that bag, 27 are blue. So they want us to set a proportion where in the second bag there are 1,000 candies. So the question is, how many are blue? So if 27 were blue out of 135, we don't know how many were blue in the 1,000 colored candy bag. So what we do there is we add a variable, because we do not know what the number is. So it's B. So in this case, we are going to review a little bit of algebra, right? So in order to find blue, we need to get the 1,000 on this 1,000 here. We need to get that 1,000 on the other side, right? Because we want to get the B all by itself. So how do we do that? We do the opposite of what we see. We see that B is divided by 1,000, so we multiply it by its reciprocal. So B times, or if there's a neater way for me to do this, there is. There's a space right over here, so we're going to rewrite it. Let's do this. 135 is equal to b over 1000. We multiply it by its reciprocal, and what you do to one side you must do exactly to the other side. That's the principle of algebra. The 1000s cancel out, and now you're left with b is equal to 1000 over 1 times 27 over 135. 1000 times 27 is, of course, 27,000 divided by 135 is equal to b. Now all we need to do is call up our calculator, and then quickly 27,000 divided by 135 is 200. So b is equal to 200. So that just means that in a bag of 1000 colored candies, 200 would be blue. Is there another way to solve this? I suppose you could try to find we knew that 27 were blue out of 135, right? So if you could find the common denominator here, if you could reduce that, well, let's keep moving. That's another strategy. Okay, so in the next problem we have what? We have 10 calculators cost $149.50. How much would 100 cost? 1,500? So if 10 costs $149.50, you have 10 at $149.50. This is testing our knowledge of the decimal system. So if 10 is $149.50, 100 would just be moving the decimal, I think, one space. So it would be 1,000. 100 would be $1,495, right? Because all you would do is multiply this 10 here by 10, right? So 10 times 10 is 100. 149.50 times 10 is 1,495. So that's, what about 1,000? Well, 1,000 would be 10 times 10 is 1,000. Therefore, you would be 14,950. Right? How about 500? Well, why don't we just divide that by 2? Because 1,000 divided by 2 is 500. And 14,950 divided by 2 is 7,475. $7,475. It's 500. I think 221 is the last problem, if I'm not mistaken. Let's take a quick look. It is. Okay. So let's take a look at the graph on the right. Take a look at the graph on the right. Name each coordinate name the coordinates of points A, B, C, and D in XY form. So again, this is probably a little bit of review. Let's just go alphabetically. A is -1, -2, -3, -4, and then 1, 2, 3. -4, rising 3. B is 1, 2 across the x-axis and 1 up on the y-axis. C is -2 on the x-axis and 0 on the y-axis. D is -1, -2, -3 on the x-axis and -1, -2, -3 on the y-axis. B says draw a set of axes just like the one shown on the right on graph paper, and then go plot the points. So don't have my graph paper handy, but I will in the future. But we'll just see if we can use the graph that they gave us. We will. E is 5, 2, so we're going to go -1, 1, 2, 3, 4, 5, and 2. So this is E. We're going to go F, which is -3, 1, -1, -3, -1. That's F. And then G is 0, -4, 0, -1, -2, -3, -4. So this is G. And H is 2, -3. So that's 2, -3. It's H. And there we have it.